Hi everyone, you know who this is by now. But anyways, we're gonna be learning about distance and midpoint formulas and circles today. So first, we're gonna be learning about the distance and midpoint formulas. And then after that, we're gonna be learning about circles. So let's start with the distance. Rather than just giving you the formula for the distance formula, I really want you to understand where the distance formula comes from. So here I randomly plotted 1, 2 and 6, 5. And suppose I want to compute the distance from those 2 points. So let me just call that distance d. To find the value of d, let me just draw myself a right triangle involving these 2 points. So here's the right triangle. What I just did was I basically went from 1, 2 straight up and then go towards right until I reach that point 6, 5. And the right angle is formed at the point 1, 5. So how many units did I go upward starting from 1, 2 to reach 1, 5? As you can see it on the graph, the distance from those 2 points is just 3, which is 5 minus 2, isn't it? So from here to here is 3. Well, how in the heck do we get that? Isn't that same thing as we did 3 equals to 5 minus 2, which is the difference of the y values between those 2 points. And now what's the distance from 1, 5 to 6, 5? Well, isn't it from 6 minus 1, which will be 5, isn't it? So let me write that out. So from here to here, our distance is going to be 5. Well, isn't that just the difference between the x values of those 2 points? Which means that 5 is same thing as, where can I write this? 5 is same thing as 6 minus 1, which is the difference in x values. So let's take a close look at this triangle. Now, what we're doing is we're going to find the value of d. Now, remember the Pythagorean theorem? It says that hypotenuse squared equals to 1 leg squared, a squared plus the b squared. It used to be c squared, but instead of c, I'm calling it a distance d. So, do you see that our d squared is going to be, I don't care which one's going to be your a or b, so let's call a to be 3. So it's going to be 3 squared plus the 5 squared, which is d squared equals to 9 plus 25, which implies that d squared must be 34. Well, how do you solve for d? Yes, apply the square root formula. But remember, when you apply the square root formula on the right hand side, you're going to have a plus and minus the square root of 34. But since we're talking about the distance, we're only going to take the positive side. So this implies that our d is going to be square root of 34. So therefore, what we just found out is that our distance d is nothing but square root of 34. Okay, now let's try to come up with a general formula for this. So instead of 1, 2, let me call this point maybe x sub 1, y sub 1. And instead of 6, 5, let me call this point x sub 2, and then y sub 2. Now let's look at that rise value of 3. That was nothing but the difference between the y values of those 2 points, wasn't it? So which is same thing as you took this 5 and then you subtracted by this 2 right here. So isn't that same thing as y sub 2 minus the y sub 1? Now let's talk about the run value, which is 5 in this case. So how do we get that value of 5? Isn't it 6 minus 1? Yeah, we got that. But isn't that nothing but a difference between those two x values? Meaning this 6 and then minus 1. That gave us the numerical value of 5. So here, if I generalize this, 6 minus 1 can be expressed as, I don't know if you can see this color very well, this is same thing as x sub 2 and then minus the x sub 1. Since it's looking pretty ugly up there, so what I did was I translated the same graph down below. Now, instead of 1, 2 and 6, 5, I'm denoting those 2 points as x sub 1, y sub 1, and then x sub 2, y sub 2. And what we just figured out was that the rise value is nothing but y2 minus y1, and then run value is nothing but x2 minus the x1. Now, since y2 minus y1 and x2 minus x1, they're distance, aren't they? So just to guarantee that our distance must be positive, I'm going to put an absolute value bar around y2 minus y1 and then x2 minus the x1. And now we're going to do the same exact thing as what we did earlier to find the distance d. So what we did was what? We just applied a Pythagorean theorem. So let me just go back to the upper little triangle. So I called 3 to be A, and then 5 was B, and then here's the distance d, which turned out to be square root of 34 in this case. All right, now in this case, our A value is absolute value of y2 minus y1, and then our B value is absolute value of x2 minus x1. So if I do the same thing as what we did earlier, which is applying the Pythagorean theorem, we're going to get a squared plus b squared equals to d squared. But who plays the role of a? That's nothing but absolute value of y2 minus y1, because that was our a, wasn't it? This guy squared plus b. Who's b? Absolute of x2 minus the x1. That's our b. And then squared equals to d squared. So how do I solve for the distance d? Yes, we're going to have to apply the square root property. But remember, this is the distance. So we're only going to take the positive side of d. So let me just swap it around. So this implies that our d, that's a d, is square root of the absolute y2 minus y1 squared plus the x2 minus the x1 squared, whole thing square rooted. Now, since something whole quantity is always going to be positive, next step I'm going to drop that absolute value sign. And then let's just put the x's first and then y next. So therefore, this implies that our d is going to be the square root. All right, I'm just going to swap around then x2 minus x1 and y2 minus y1. And then drop that absolute value to write x2 minus the x1 squared plus y2 minus y1, whole thing squared. And here is the distance formula. And yes, please memorize this formula. So here it is. Distance formula. The distance d between 2 points x1, y1 and x2, y2 is given by d equals square root of x2 minus x1 squared plus y2 minus y1 whole quantity squared. Now our next topic is, how do I find that midpoint of that line segment that's connecting x1, y1 and then x2, y2? Now, does this point look like a midpoint of this line segment? Well, please pretend that that's a midpoint. So our midpoint, what we want to do is we want to try to come up with a formula for it. Now, the midpoint of a line segment is nothing but an average of the x coordinates and the average of the y coordinates of the endpoints. So what is the average of the x coordinates of the endpoints? That's nothing but x1 plus x2 dividing by 2. That's the average, isn't it? Because you're adding 2 points and then you're dividing by 2. So our x coordinate for the midpoint is going to be x1 plus x2, whole thing dividing by 2. And then we're going to do the same thing with the y coordinate. The average of the y coordinate of the endpoints is nothing but y1 plus y2, whole thing dividing by 2. That's an average. So our midpoint formula is given by this. Don't worry, we're going to summarize this in a minute. So here's the midpoint formula. It says that the midpoint of the line segment, whose endpoints are the 2 points xy, y1 and x2, y2 is, I just denote it by m, stands for midpoint. M equals x1 plus x2 all over 2, comma, y1 plus y2 all over 2. So please note that this is the x-coordinate of the midpoint. And of course, this is the y-coordinate of the midpoint. I think we're ready to do some examples, so let's do it. Example 1, find the distance and the midpoint of the line segments whose endpoints are given by -2, -1 and 3, -4. So first step, what we need to do is let's label which one is going to play the role of x1, y1 and then x2, y2. Well, it does not matter which ordered pair that you're going to call as x1 and y1. So let me just go in order. So I'm going to call this guy x1, y1. And I'm going to call 3, -4 as x2, y2. Now let's first go with the distance. So our distance d is given by square root of x2 minus x1 squared plus y2 minus y1 squared, whole thing being square rooted. Alright, so all we're going to do is we're just going to plug and chug. Alright, so here you're going to get a square root of x2. x2 is 3 minus x1. Be careful. X1 is -2, but you're going to have a minus sign in front of that. So here you're going to have 3 minus 2 squared. And then plus y sub 2 is -4 minus y sub 1, which is another -5 squared. And then whole thing being square rooted, which is same thing as the square root of, so this portion's become 3 plus 2 squared, and then -4 plus 5, whole thing squared. I'm trying to work this step by step. So what do we got? We got this to be 5 squared, and then plus 1 squared, whole thing being square rooted. So it looks like our distance is going to be square root of 25 plus 1, which is square root of 26. Let me box this, and I'm a very visual person, so I had to draw it out. So here's what's going on. All I did was I just plotted those given 2 points, -2, -5, and 3, -4. So what we just discovered is that the distance between these 2 points is nothing but the square root of 26. Now let's talk about the midpoint. Midpoint formula is given by, is an ordered pair. x1 plus x2 all over 2 is the average of the x values, and then y1 plus y2, whole thing dividing by 2. Alright, so ready? So we're just going to plug and chug those given numbers. So x1, who's x1? -2 plus x sub 2 is 3, whole thing dividing by 2, comma, so that's going to be the x-coordinate of our midpoint. And then y1 is -5, and then plus y2, -4, whole thing dividing by 2. And that's going to be the y-coordinate of our midpoint. So what do we get here? We're going to have, looks like we're going to get 1/2, comma, -9 over 2. Since we need to plot these points, so let me just reduce this down to 1/2, comma, -9 over 2 is same thing as -4 and 1/2. Alright, so let me box this. And what we just found out is that our midpoint is going to be 1/2, comma, -4 and 1/2. So it's basically right here, isn't it? Does it look okay? So this point is our midpoint, which is 1/2. Let me just go with m equals 1/2, comma, -4 and 1/2. So key to finding out the distance and the midpoint of a line segment is memorizing those two formulas. So please write this down on your note card or on your notebook and try to memorize them both. Our next topic is a circle. Now, yes, of course, we all know what the circle looks like, but in a math classes, there is a formal definition to define a circle. So let's just go over this together. A circle is all points in a plane that are a fixed distance from a given point in the plane. The given point is called the center, which is denoted by h, k, and the fixed distance is called the radius, denoted by r of the circle. So here's the situation. We got the center, and the fixed distance from any point on the circle is called the radius. So here what I did was I randomly chose a point on the circle, and then I'm going to call it x, y, and center is always denoted by h, k. To come up with the equation of a circle, we need to apply the distance formula, and that's the reason why we learned about the distance formula before the circle. But note that our distance formula was given by the square root of the difference in x, which is x2 minus x1, squared, and then plus the difference in y, y2 minus y1, squared, whole thing square rooted. That was the distance formula. Now instead of a d, we have a r there. So I'm going to replace our d, distance d, with a radius r. We're going to do the same thing. So we got r equals square root. Well, change in x will be x and then minus h, because h is the x coordinate of the point h, k. So here you're going to have x minus h squared, and then plus, now let's look at the difference in y values. Well, y values for both points are y and then k. So I'm just going to go with y minus k, whole thing squared, and then whole thing square rooted. I'm just following the distance formula. Now, if I want to get rid of that square root, I need to square both sides, correct? So if I do that, then we're going to have r squared equals x minus h squared plus d, y minus k, whole thing squared. And guess what? This is the equation of a circle in standard form. So here it is, standard form of the equation of a circle. The standard form of the equation of a circle with center h, k and radius r is given by x minus h whole quantity squared plus y minus k whole quantity squared equals r squared. Example time. Example 2. Write the standard form of the equation of the circle with radius of 7 and centered at 2, -4. So first, I'm going to write down the formula for the circle in standard form, which is x minus h squared plus d, y minus k squared equals d, r squared. All right, so all you have to do is just plug those given points in. So let me see. 2 plays the role of h, and then k is the -4, and radius r is 7. So all you have to do is just plug and chug into that formula. So here what we're going to get is x minus h, which is 2, squared plus y minus k, which is -4. So be careful, you're going to have a minus 4 squared equals 7 squared. So we get x minus 2 squared plus y plus 4 squared equals 49. And there it is. That's the equation of a circle in standard form. So I'm going to box that for our answer. Now let's take a look at something like this. Write the standard form of the equation of the circle with center at 2, 3 that also contains the point -2, 1. So just so that we have a better understanding of this, let's draw a picture. So here, all I did was bust out the graphing paper and plotted those 2 points that's given to us, which is the center and a point -2, 1. Well, what are we missing? In order for us to write the equation of a circle, remember, you need that radius. So first, we need to compute that radius, which is nothing but a distance between those 2 points. So here's the rough sketch of that circle that we're talking about. So first, we need to compute that radius. which is nothing but a distance between those 2 points. So let's do it. So first of all, our r is same thing as the square root of x2 minus x1 squared plus the y2 minus y1 squared. Same thing as the distance formula. Before, this guy was d, but instead of d, we're calling it r. So here what we're going to get is the square root. Well, it doesn't matter which one you want to call it, x1 or x2, but let's just call this one x1, y1, and then negative 2 comma 1 as x2, and then y2. Okay, so I'm going to go in that order. So then here what we're going to get is x2, which is negative 2, minus x1, which is 2, squared, and then plus y sub 2. Y sub 2 is what? 1, minus y sub 1 is 3, whole quantity squared, square rooted. So this is going to give us square root of negative 4 squared plus 1 minus 3 is negative 2, whole thing squared, which is the square root of 16 plus 4, which is square root of 20. And square root of 20 can be simplified to 2 square root of 5. So what I'm going to do is I'm going to box this for the answer. Since we're going to have to square r at the end, so I'm just going to box both of them. Okay, so I think we're ready. Let's write down the formula or the equation for the circle, which is going to be x minus h squared plus y minus k squared equals to r squared. Now remember that h is the x coordinate of the center and k is the y coordinate of your center. So 2 is h and then 3 is our k. Alright, now let's do this. So this implies that we're going to have x minus our h is 2 squared plus y minus our k is 3 squared equals to r squared, which is same thing as square root of 20 whole thing squared. So this is going to give us x minus 2 squared plus y minus 3 squared equals to 20. And that is it. That is our equation of the circle in standard form. Example 4. Find the center and the radius, then graph x minus 3 whole quantity squared plus y plus 4 whole quantity squared equals 4. Okay, this is not as bad as you think because this equation is in standard form. So if I write the standard form right directly below, this is same thing as x minus h squared plus dy minus k squared equals to r squared. So notice that our h and a k and x and a y, they're separated by the minus sign. So keep that in mind, and what I'm going to do is I'm going to take our equation and rewrite it with the minus sign in between x and a h and then y and a k. So here we're gonna have, well, this guy's okay, we got x minus 3 squared, and then now let's look at the y. Now here you're gonna go y minus, so in this case what do we need to have to get a positive 4? That will be negative 4 squared equals 2. Now 4 is same thing as 2 squared, so I'm gonna rewrite it just like that. So now notice that between x and a h and then y and a k, we have a minus sign. So we are good to go. So 3 is going to be our h, and then negative 4 is going to be our k, and then our r is going to be 2. So let me write that out. So h comma k, so which is the center. This is 3 comma negative 4, and the radius is 2. So let me box this for the answer, and now let's graph it. Let's first jot down the center. Center is 3 comma negative 4. So that will be right here. So I'm gonna call it C, stands for center, 3 comma negative 4. And then the radius has to be 2. So that means that from the center, you're going to have to go 2 units to the left, and then also 2 units to the right, then 2 units above, then below. And our circle has to touch the tip of the radius. And what I'm going to do is I'm going to use this beautiful app to draw myself a beautiful circle. Ta-da! So here it is. For next example, let's do something a little bit different. Before we go over the next example, we need to know one more form for the equation of a circle, and that is called the general form of the equation of a circle. So the general form of the equation of the circle is given by x squared plus y squared plus ax plus by plus c equals 0. And let's just recall the standard form. It was given by x minus h squared plus y minus k squared equals to r squared. So when you look at the general form and the standard form, they look completely different. So let's just give ourselves one example of the equation of the circle in the standard form, and let's expand it. So for instance, I don't care what number that we want to pick. What do we want? So maybe x plus 2 squared and then plus y minus 3 squared equals maybe 16 or something like that. I just made that up. Okay, so now what I'm going to do is this. I'm going to expand this out. Okay, so that means that x plus 2 whole quantity squared is same thing as x plus 2, and then x plus 2, and then plus y minus 3 whole quantity squared is same thing as y minus 3, and the right hand side is 16. Now let's FOIL. So here what we're going to get is x squared plus 4x and then plus 4. Do you see what I just did? I just FOILed it like this, and then doink, and then doink. All right, and then plus, if I FOIL y minus 3 times y minus 3, what we're going to get is y squared minus 6y plus 9, and then equals 16. Okay, so now let me just rearrange it in this way. So I'm going to go x squared, and I'm going to bring this y squared next, plus the y squared, and then plus 4x minus 6y. Now I think we could combine 4 and a 9 to get 13, plus 13 equals 16. Now let's bring the 16 on the left hand side by subtracting both sides with 16. So then what we're going to get is x squared plus y squared, and then plus 4x minus 6y, and then here you're going to have minus 3 equals to 0. All right, so let me just box this and take a look at the general form above. Isn't this nothing but the general form? So guess what? When you expand the standard form, you can get to the general form. Well, now what we're going to have to do is, given the general form, how in the heck are we going to get back to the standard form? So what do you think? Yes, we need to complete the square on x and also on y. Now, before I start doing this, let me just take a look at this guy. Okay, so can you tell me what kind of circle that is? Well, so this is nothing but a circle with the center negative 2, 3, that's a center, and the radius is 4. So that will be the circle. Now, all I did was just expand the standard form to get the general form. So guess what? When you graph the standard form, and then when you graph the general form, they better have the exact same picture. I know they look completely different, right? But anyways, let's do some examples. Example 5, find the center and the radius of the circle. X squared plus y squared plus 6x minus 2y plus 1 equals to 0. So, are you guys ready? What we're going to do is we're going to complete the square on x and then also on y. So let me just first rewrite it like this. I'm going to bring the guys with all the x's attached on it first. So here you're going to have x squared plus 6x. And you know what? I'm going to leave a little room because I'm going to have to complete the square. And then I'm going to bring down the y squared, all the one with the y's attached on it. So we got y squared and then minus 2y. And then we got plus 1 equals to 0. All right, so do you remember how to complete the square? Let's do this together. So first, what we need to do is divide a middle number by 2, including its sign. So here you're going to have plus 3. Now remember what goes in here, what you need to add in? That's 3 squared. So you're going to have to add in the 9. But you cannot just randomly add the 9 on the left-hand side of the equation. Whatever you do to the left, you better do the same thing on the right-hand side of the equation. So if I'm going to add 9 on the left-hand side of it, I need to add 9 on the right-hand side of the equation. And now let's write this in terms of a perfect square. So remember how to write it? So this is going to be x, and then this number is going to go in next, plus 3 squared. All right, so that part is done. Now what we need to do is we're going to complete the square on the y. We're going to do the same thing. So first I need to divide a middle number by 2. Then here you're going to have negative 1. And then what goes in here is negative 1 squared. That's the quantity that you need to add in. So that will be plus 1. But the thing is, again, I cannot just randomly add 1 on the left-hand side. I better be fair and add 1 on the right-hand side as well if I'm going to do that. So now let's try to rewrite this expression here in terms of a perfect squared. Then here you're going to have y minus 1 squared. Now don't forget to drop this plus sign in between. A lot of students forget that. So I'm going to just put this plus here. Okay, and then what do we got? And we still got the plus 1. And then on the right hand side, 9 plus 1, it's going to give us 10. And next step, I'm going to bring the 1 on the right hand side by subtracting 1 from both sides. Then looks like we're going to have x plus 3 squared plus y minus 1 squared equals to 9. So look at it. Now, is this in standard form? Yes, it is. So this is the equation in standard form. Now let's go with the center and the radius. So the center is always going to be at h comma k. In this case, you're going to have negative 3 comma 1. And the radius, remember 9 is radius squared value. So you need to take the square root of 9 to get the radius, so which will be 3. So here it is. And again, the graph of the equation in standard form and general form, they're going to give us the same exact graph. So if you graph the original equation in terms of a circle, then that's nothing but a circle at a center at negative 3 comma 1, and the radius is going to be 3. So what I wanted to mention is that these two have the same exact graph, although they look completely different. Now let's try this example. Same thing, find the radius and center. Now I'm going to ask you to graph this. So let's see if you can do this on your own. So please pause the video and try this on your own. Alright, so I'm going to start out with x squared and then plus the 12x, leave a little room, plus y squared minus 14y, leave a little room, and then you know what? You can bring that 21 on the right hand side of the equation by subtracting it already if you like. So let me just do that. So first I'm going to go minus 21, or you can do this step at the very end. So here what we're going to get now is minus 21. Alright, so now let's complete the square. So I need to divide this number by 2. You're going to have positive 6. And then 6 squared is going to go in here, so I need to add in 36. That means I need to add 36 on the right hand side as well. And now let me just write down the perfect squared here. So this is same thing as x plus 6 whole quantity squared. And then don't forget to drop this plus sign. Now let's complete the square on the y. Divide this by 2, you're going to have minus 7. Here you're going to have minus 7 squared. That's the quantity that you need to add in. So that will be plus 49. And I'm going to add the same quantity on the right hand side of the equation. Alright, so now let's try to express this in a perfect square form. So this is same thing as y minus 7 whole quantity squared. Now this whole thing equals to negative 21 plus 36 and then plus 49. And what is that? 64. So let me just rewrite it nicely. So we got x plus 6 squared plus y minus 7 whole quantity squared equals to 64. Alright, so we got our equation of the circle in standard form now, which means that, yes, now we can find the center and the radius. So let's go. So ready? Center is h comma k. So this will be negative 6 comma 7. And the radius is square root of 64, which is 8. So let me box that. So here is our center and radius. Now I think we are ready to graph. Alright, so let's first jot down the center. Center is at negative 6 comma 7, so that will be negative 6 comma 7. Did I plot this right? Negative 6 comma 7? Yep. So I'm going to write it as negative 6 comma 7, and that's going to be our center. Now the radius is 8. So from this point, from the center, you're going to have to go 8 units to the right, 8 units to the left, 8 units above and below. So let's see if I can do this. So towards the right, you're going to have to go 8 units. So from here to here is 6, and then here to here is 2. So, I kind of exceeded a little bit, but this will be the end point of the radius. Now let's go, oh no, I'm going to run out of room here. Oh well. Alright, so let's go to the left 8 units. Then we're going to be ending at x equals to negative 14. And if I go down 8 units, our y value is going to end up at, where is it? Negative 1. And if I go 8 units above, I'm going to be out of this graph, but it's going to be at 15. Y equals to 15. So that will be maybe here. And now all we have to do is connect those 4 dots to make a circle. Alright, here it is, and this is the best I can do. So maybe I need to just cheat a little bit and bring the dot here. And now it looks so perfect. And so that is the circle graphed by our equation x squared plus y squared plus 12x minus 14y plus 21 equals to 0. So what was the most difficult part of doing this example? Was it the math portion or was it the graphing portion? Well, mine personally, you have no idea how many times I tried to draw that circle. I paused the video before I drew the circle, and it literally took me 27 minutes to be exact to draw that circle. So I'm gonna keep this circle forever. Anyways, I'm gonna stop here. So if you have any questions at all, please let me know. And good job once again, everyone. Keep it up.